6.3, similar and congruent figures. So we get a little geometry today. And what we're going to do is we're going to use the ideas that we were studying in the last two lessons on ratios and proportions, and we're going to bring that into the idea, the geometric idea of what we call similar figures. Similar figures are two figures that have the same shape, but not necessarily the same size. A great example of similar figures are circles, because all circles have the same shape, but they can be different sizes. Okay, think of it like a bullseye like an archery field. Now note this little squiggle right here, this one, it means is similar to. That means that, again, they have the same shape, not necessarily the same size. They could have the same size, but more times than not they don't. Now there's some key properties of similar figures, and what I had to do to introduce this is I had to bring in the idea that I have two triangles, triangle ABC and triangle DEF. I've got them down here. And they're similar to one another. They're supposed to have, and I drew them so they're not perfect, but they're supposed to have the same shape, just that this one's a little bit bigger than that one. I can't draw them perfectly, but hopefully you get the idea. Now there are two key properties here. The first one is that the corresponding angles of similar figures are equal in measure, or congruent. Equal in measure for angles means that the angles are congruent. If you've never heard that term before, it's an equal sign with the little similar symbol above it. This means it's congruent to. Now notice here the way I list the order of the three vertices, the 3 points. I have A, B, C, I have D, E, F. Now look at my drawings here. See how I have one little arc symbol there and one little arc symbol there? That's to show that these two angles are congruent, that they have the same measure. Notice also that they're the first letters in the listing of the name. Then I've got this one right here with the double arc and this one here with the double arc. Angles B and E are congruent. They're the middle letter of each of the names. So here's angle A is congruent to angle D, angle B is congruent to angle E. This one with 3 arcs and this one with 3 arcs, angle C and angle F, they're congruent. That's what the symbols mean. So I write that angle C is congruent to angle F. Notice they're the last letters of the listing of the name. So how we write the letters for the vertices of the figures is extremely important. Now if this is given to us, this gives us a ton of information. It tells us which angles are going to be congruent to one another. That's a key property. A second key property, and the one that brings in the idea of proportions, is that the ratio of the lengths of corresponding sides of similar figures are equal. Now that means this side from A to B, that goes from 1 arc to 2 arcs, but the length of the side, this line segment right here, and over here, DE, that's this line segment right here, goes from 1 arc to 2 arcs. AB, the first 2 letters, DE, the second 2 letters. The ratio, they're not equal because I have different sizes here. The ratio of their measures is the same as the ratio of the measure of this one, BC, from 2 to 3, and EF from 2 to 3 again. So this ratio of big to little, AB to DE, is the same as this ratio, BC to EF, from big to little. Now I'm going from big to little, that's just the way I happen to draw it out. You could go from little to big. And that also brings in one other set of sides, side AC and side DF, from 1 arc to 3 arcs. You see right there, AC and DF? So the ratio of big to little, big to little, big to little, those are equal. So I've got 3 proportions. I've got this proportion, I've got this proportion, and I've got this proportion. So with that, I can solve for missing lengths of sides, and that's all sorts of interesting concepts that can come up. All right, so properties of similar figures, corresponding angles are congruent, and the ratio of the lengths of corresponding sides are equal. Let's try a couple of examples. Given triangle STU is similar to triangle VWX. Name the corresponding angles and the corresponding sides. Well, I can do this without the diagram. I don't need the figures drawn out for me because it's key on how the letters are ordered. For example, at vertex S, it matches up with V, T matches up with W, and U matches up with X. So that tells me that angle S corresponds to angle V. Angle T corresponds to angle W, and angle U corresponds to angle X. It also tells me what sides correspond. So you go the side that connects the first two vertices here, ST corresponds to VW. TU corresponds, that's the last two letters, to WX. And you have to say WX. You couldn't say XW. You must have them in the same order. And then SU corresponds to VX. Just by looking at the way that the names of the triangles are listed, or the vertices are listed, you can tell which ones of the angles are corresponding, which ones of the sides are corresponding. Now, here I have a diagram. It says, given FGHJ, that's this quadrilateral, is similar to KLMN, that's this bigger quadrilateral. Find the ratio of the lengths of the corresponding sides. Now, this is a ratio. I'm not setting up a proportion. I just need the ratio of the corresponding sides. But I'm going FGHJ, that's the bigger one, to KLMN, that's the smaller one. So I'm going from bigger to smaller. Well, look right here. FJ, that's this one, FJ, and KN, that's this one. You see how they correspond? FJ corresponds to KN, that's this one right here. Well, their sides are 4 to 3. And that's my answer right there. Don't change it into a mixed number. They want it as a ratio, so we're going to leave it in fraction form. That's my answer, just that simple. Now, I could have done the same thing using these two sides because NM, that's the last, and then that's the next to last, and JH, last, next to last. And if you write the ratio of this one over this one, it would simplify down to 4 to 3. Third example here. The top of Mia's rectangular dining room table measures 60 inches by 108 inches. So it's a rectangle, it's a dining room table. She has a matching rectangular coffee table, matching probably in color and style, not necessarily in size. She has a matching rectangular coffee table whose top measures 18 inches by 48 inches. Are the two tables similar? Well, the angles are going to be, the corresponding angles are going to be congruent because they're rectangles, and all four angles of a rectangle are 90-degree angles, right angles. So that's going to match. What we have to do is determine if corresponding sides are proportional. So what I'm going to do is I'm going to take the short side of the rectangle and I'm going to compare it to the short side of the other rectangle, from the dining room table to the coffee table. I'm going to write 60 is to 18. I'm going from the bigger one to the smaller one here. Then I'm going to take the lengths here and here, that's the two larger measures, and I'm going to write the ratio here from the larger one to the smaller one, that's 108 is to 48. Are these equal? If they're equal, my answer is yes, the two tables are similar. If these are not equal, then my answer is no. So in this case, the best way to see if a proportion is true is to see if their cross products are true. Multiply these two together, the extremes. So I have 48 times 60. That's a 0. That's an 8. Carry 4. That's 2880. 2,880. Does that equal? Then look at this cross product here, the product of the means. That's 108 times 18. I can see it's not going to work because it's not going to end with a 0. 4, 6, 8, 8, 0, 1, 4, 4, 9, 1. I get 1944. Well, you can see that these are not equal, and therefore your answer is no. They're not similar. The cross products would have to be the same for them to be similar. Now, congruent figures, they have more stuff going for them than similar figures. Congruent figures are two figures that have the same shape and they have the same size. So the exact same shape, the exact same size. Corresponding angles are congruent, corresponding sides are congruent. Now technically congruent figures are also similar figures, so the same properties apply. But since they're congruent, the sides, we don't have to worry about being in a particular proportion. The corresponding sides are congruent to one another. All right, so here I have two triangles. I've got triangle FGH is congruent. Remember, this is the congruent symbol to triangle KJL. And I'm defining the indicated measures down here. Now it says here to find JL. Now without the little line bar above it, that means the length, the measure of line segment JL. JL over here JL, over here, is the last two letters. So the last two letters, GH. GH is 21 inches. Corresponding sides right here, and corresponding sides are congruent, so this is 21 inches. That was easy. Now, the second part, find the measure of angle J. All right, the measure of angle J, that's the middle letter. What's the middle letter over on this one? G. So angle G and angle J correspond, and if angle G is 60 degrees, then angle J is 60 degrees. This little m in front of the angle symbol means the measure of angle J, and it is equal to 60 degrees. All right, so look these over and practice, practice, practice.